Hello everyone, in this tutorial let's go through hardware architecture of a sensor node. Hardware architecture of a sensor node mainly consists of three units. One is power unit, sensing unit and processing unit, followed by transceiver. So these are all the four main basic units that which are mandatory in any kind of sensor node. And here they have represented optional blocks in these dotted lines. So this power unit may also contain optional power generator unit. In a similar way, these sensor nodes can also be associated with the location finding system as well as mobilizer. And all these units, sensing unit, processing unit and transceiver unit, they are all powered by this power unit. So thereby there is an outward going arrow mark connected to all the three blocks. Then there is again outward going arrow mark from power unit to location finding system. That is, most of the times it's GPS, or this localization can also be implemented through a software approach. And because this unit gives the location information, so this is acting like an input for processing unit, because for most of the cases we might need the location information. Then we have one more arrow mark going into the mobilizer block from the power unit, and most of the times these sensor nodes have to be mobile in nature. So thereby in order to give actuation commands to this mobilizer, there is one more outward going arrow mark from processing unit to this mobilizer. So this sensing unit consists of two components. One is it can have a single sensor or multiple sensors, so that is why sensors are used, and one more subunit called as analog to digital converter. So whenever a physical activity is sensed, that sensed parameter is in turn converted to digital form, because most of the signals are analog in form. So after converting into digital form, that digital data is in turn passed on to this processing unit. In processing unit, we have two subunits, processor and memory. So processor is a place where we can run our algorithms, and here is where we can manage sensing and do collaboration with other neighboring nodes. And after processing that data, we can pass on the collected data by the help of this transceiver, where bits are in turn converted to RF waves, radio frequency waves, and with the help of an antenna, this can be wirelessly be passed on to the other relaying nodes. So power generator can be made up of solar cells for outdoor applications. So basically this power unit is made up of lithium ion kind of battery, that which has very high power density. So this wireless sensor device, it generally consists of four main components: sensing unit, processing unit, transceiver unit and a power unit. In additionally to that, it can also have location finding system, power generator and mobilizer. Sensing unit. The sensing unit is the main component of wireless sensor node that distinguishes it from other embedded system with the communication capabilities. The sensing unit may generally include several sensor units which provide information gathering capabilities from the physical world. Each sensor unit is responsible for gathering information of a certain type, such as temperature, humidity, light, and is usually composed of two subunits, sensor and analog to digital converter ADC. The analog signals produced by this sensor based on the observed phenomena are converted to digital signals by the help of the ADC and then fed into the processing unit. Processing unit is the main controller of the wireless sensor node, through which every other component is managed. The processing unit may consist of an onboard memory. The processing unit manages the procedures that enable the sensor node to perform sensing operation, run associated algorithms, collaborate with the neighboring nodes through wireless communication. And then we have this transceiver unit, where communication between any two wireless sensor nodes is performed by the transceiver units. A transceiver unit implements the necessary procedure to convert bits to radio frequency waves and recover them at the end, on the other end. Essentially, the wireless sensor network is connected to network through this unit, power unit. One of the most important components of wireless sensor node is the power unit. Usually battery based power is used, but other energy sources are also possible. Each component in wireless sensor node is powered through power unit, and the limited capacity of this unit requires energy efficient operation. So because most of the times it's battery operated, so it has to be used in a limited capacity to perform tasks by each component. Then we have this optional location finding system. Most of the sensor network application, that is sensing task and routing techniques, need the knowledge of physical location of a node. Thus, it is common for a sensor node to be equipped with location finding system. This system may consist of GPS module for higher end sensor node, or maybe a software module that implements the localization algorithms that provide location information through distributed calculation. So here GPS is suited only for high-end nodes because the cost of the GPS module itself is 3 times that of the sensor node. That is why these GPS modules are only limited to nodes called as beacon nodes, that which will be in very limited in number compared to that of normal sensor nodes. Then we have mobilizer. A mobilizer may sometimes be needed to move the sensor nodes when it is necessary to carry out the assigned tasks. Mobility support requires extensive energy resource and should be provided efficiently. The mobilizer can also operate in close integration with sensing unit and the processor to control the movements of the sensor node. And finally, we have this power generator. While battery power is mostly used in sensor nodes, an additional power generator can also be used for applications where longer network lifetime is essential. For outdoor applications, solar cells are used to generate power. Similarly, other energy scavenging techniques can also be used, like thermal, kinetic and vibration energy. And in our next tutorial, let's go through power consumption in wireless sensor network.